Hi guys, let's solve today's Leetcode problem, and it is problem number 1391. Check if there is a valid path in a grid. Okay, it's a medium problem. Let's read this out. You're given a m cross n grid. Each cell of grid represents a street. The street of grid of I can be 1 means street connecting the left cell and right cell. 2 represents street connecting upper cell and lower cell. And similarly for 3, 4, 5, and 6. Okay. If you see in this case, this is the street 1 which connects the left cell, whatever it is, and the right cell. Okay. Because this is a road like this. Okay. Now, so for street 2, it connects the top one and the bottom one. For street 3, it connects the left one and the bottom one. For street 4, it connects the bottom one and the right one. And similarly, if you see for street 5, it connects left and top. For street 6, it connects top and right. Okay. So this is what the grid of I can be. It can be any value from 1, 2, 3, 4, 5, 6. So what the question is saying is you will initially start at the street of upper left cell. Basically we have to start from this cell, and a valid path in a grid is a path that starts from upper left cell 0 0. Here it starts from here and ends at bottom right cell, that is m minus 1 n minus 1. So we have to start from this cell 0 0, okay, and end at n minus 1 comma m minus 1, or whatever mn you can keep it. Okay, so it will end here. The path should only follow streets. Okay, the path should only follow the streets, and notice you are not allowed to change any street. Return true if it is has a valid path, else otherwise false. Okay, so constraint, if you see this m and n can be up to 300. So the brute force approach, if we normal brute force approach we apply, it will work. Okay, now this grid of I is up to 6. What we have to do is we have to start from 0 comma 0 and go till m minus 1 to n minus 1, and we can only go if there is a valid path. If you say in this example there is a valid path. Okay, so if I just see, we started from here, I can go up to here, and I came here. Okay, I started from this cell and ended at this cell, so there is a valid path, so that's why we return true. Okay, now let's see this example. In this example, you see we started from here, but from this place, you see we can have either gone to left or right. Left is out of the boundary condition, so we can go left. And right, if you see, right also there is this cell which connects up to up cell and down one. It doesn't connect through the left cell. Okay, since there is no connecting path over here, or like this, anything like this, so we cannot go anywhere from this path itself, this node. So from here it is not possible to from move to any node, so that is why from for this case the answer is false. Okay, let's see how we will solve this problem. So normally this can be solved using DFS, and this is normal grid problem, where we have to start from 0 0 to n minus m minus 1. We have to go to this last cell. This is normal, that approach. Only the difference, if you see, in normal DFS what we did is we normally had 4 direction which we can go from any cell. Okay, from any cell we can go either left, right, up or down. Okay, so this was the normal DFS where we can go like this. But in this case it is saying that if the cell has value 1, then it can go to left or right. You see this street 1, then we can go left or right. Similarly, if the value is 2, we can go up or down. Okay, so up or down. So this is the constant. Now in normal cases we can go normal DFS, we can explore all this path, but in this case we can explore only this path. Okay, for whatever value this grid holds, we will only explore those possibilities. Okay, so now if we just simply explore these possibilities, keep on exploring, then we would be able to reach to that value. Now let's say I am at this index 1. So I am here at something like 1. Okay, so here it is 1, and here let's say it is 2. So 1 means something like this, it will be there. 2 means, if you see, 2 means, yeah. So if you see, we started from there, and now from here we have to go. So from 1 I am saying that I can go either left or right. Okay, now I came to right, but how do I know, I came to right, but was there a valid part to come to right or not? I mean, this is possible place where, I mean, I can go to left and right, but even if it is possible to go to left or right or not, we need to know that, right? Because in this case, if you say this was 1, this is 2, there is no possibility that I can come to this path, right? So we need to validate if it is possible or not. If it is possible, then only we can go. So how can we validate that? Okay, so we need to notice one thing from this case. We see from, if we just do, normal our computation for this value left and right. So if this was a I comma j index, so above if we go, so I would be I minus 1, j would remain same. For right it would be I will remain same, j will be j plus 1. Down it would be I would be I plus 1 and j would be j, and for left I would be I and j would be j minus 1. Okay, so this is basically how it is, how indexes change if we are at index ij and we go to left, right, and so. Now let's say the value is 1. So from 1, where we can go to left or right. Okay, so for left, what was the value? So for left, if you see, I is we are how much value we are adding to I, it is plus 0, right? So it would be 0 and minus 1, and to right 0 and plus 1. Similarly for 2, if we see, so 2 we can go up, up and down. What is for up? Up we can minus 1, I need to be minus 1 and j is would be 0, and for down it is 1 and 0. Okay, so similarly we will write these values from where all we can go and what will be the indexes that will be getting changed. I'll just quickly write this out. Okay. Okay, so now I have written all this indexes where I can go if my values are I 1, 2, 3, and so on. So if I go left, right, and all, what will be the index that will be changed to? So I have written all this, and now let's say we were at index 0, comma 0. So from 0, comma 0, where we can go? We can go to 0 plus 0, so it would be left and right. So it is 1, right? Value is 1. So from 1, where we can go? We can go this 0 comma minus 1 and 0 comma 1. Okay, so these are two values where we can go. Now if you see, this is out of bound index, minus 1 is out of bound index, so we won't consider this. Now we'll consider this one, that okay, we can from this index we can go to right. Now when we went to right, now we need to see if there is a direction, reverse direction from 2, it is possible or not. I mean, there is a path or not. So this was our 1, and this is where we are, and we need to check if there is a direction or there is a path or not. So from here we will do a reverse direction check. So from 2, where all we can go? So from 2 there is two possibilities we can go, either up or down. So again, in this indexes, we will add this value for up and down. You see, these are the values for up and down. So to 0 and 1, if we add, so it would be minus 1, and it would be 1. And if we go down from there, so down would be 1 comma 1. Okay, so from 2 we can go to these two places. Now we, for these two we will check. Okay, so this one, if we check this, is this equal to our this value? No, this is not equal, so we cannot go to 2 using up. Now we cannot go back to 1 using up. Now if we check this value, compare this, is do to these two equal? No. So which means we cannot go back to 0 comma 0, that is 1 from 2, which means there was no path, though there is a possibility that from 1 we can go either left or right, and we tried that. But from when we went to right, basically this is our new index, and when we went to right, we checked if it is possible to go back to this or not. So going back would be adding, getting the new index where all I can go from 2. So since 2, from 2 we can go to left and up, and we compared if going left and up, by any chance can I go back to 1? If no, which means this is not a valid path. So this was not a valid path. That's why we were not able to do. Okay. So this is how we are going to do. So if I just write down in, steps what we actually did. So one was, uh, we need to store the directions where all we can go in what all grid values. And the second thing is, we need to, a normal, this is a normal DFS call, only direction is changing. So as I already told, normally we were able to, in normal DFS call, for from a cell we were able to visit all 4 directions. But here the only part which is changing is direction. So in normal DFS, what we need, we also need a visited array, visited grid or whatever, to store if we have already visited, so we don't need to, revisit the same path, because in the question also I think it has said that we cannot cross the same route or something. So that is, we will have the visited array, and then we will make the DFS call. And from DFS call, uh, at any point, if we reached, our last index or our, end goal, then we can say okay, we have found it. If not, then we will continue searching. All this sort of things will mark the current indexes, visited, and from the current index, we will find the next indexes. Okay, next indexes we will find, and from next indexes, if it is, we will have this out of bound check if that index is out of bound or not, and if it is not, then we need to check the reverse direction if it is possible to, go back to that particular node, from, I mean, that particular cell, from the new cell that we are in. If it is possible, then we can continue with, we can continue our DFS check for finding the next route. Okay, until we reach the our end goal, that is n minus 1, m minus 1. And if it is not possible, then we'll try the other directions, as I told, right? So from 2, there was 2 possibilities, either up or down. With 2, it was not possible, then we tried for down also. And similarly, I mean, first we will try from 1, we can go to, this was left and this was right. So first we did for left, if it is possible or not. If it is not, then we will try for right. And again, for each of them, we have these 2 possibilities as per the streets that we are given to us. Okay, I hope you understand this approach. Let's now write the code for this. So first step, as I've mentioned, we need to have this direction. This direction, I can store this in an ordered map of, integer comma vector of int, or I can simply store as vector of pair of int. Anything would work. So an ordered map of int comma vector of int comma int. I'm just writing shortcut. Okay, this v means vector. Yeah. So of directions. Okay, I'll just write the directions from what we have above. Yeah, so first step is done. This was our first step where we created our direction. Now we can, have our method saying, you know, our main method where we will create this visited array of, so this n would be of, grid of grid dot size, and m would be grid of 0 dot size. Now this vector of and visited of size n, vector of end of size m comma 0. This is our visited array created, and from here this is our method, boolean, bool has valid path. whatever our input is given, grid. So we can return the DFS starting from 0, 0, and we can pass visited and grid. Okay, now let's look at this DFS function. So DFS would be and I and j and then visited and the grid. Okay, so first thing in this DFS method, we need to check if we have reached our end goal, that is I is equal to n minus 1 and j is equal to m minus 1. If we have reached to our end goal, then we can return true, that there is a valid path through which we have reached our end goal. Okay. Otherwise, we will mark this node as visited, marking this cell as visited. And next thing is to the steps, if you see. So one is directions, then visited array and marking it, and then we need to do the DFS call and things accordingly. So DFS, where here we need to iterate through all the directions that we can go from this particular cell. Okay, so what all directions that we can go from this particular cell, so this has been mentioned here. Okay, so I can write something like auto direction of directions of grid of ij. Okay, so this will give me all the directions where I can go from this particular cell. Then we will calculate the next I value would be I plus this direction of 0, and next j would be j plus direction of 1, and here we'll check if this is out of bound check, if n of I is 0 less than 0 or n of j is less than 0 or n of I is greater than equal to m, or n of j is greater than equal to m, or the cell is already visited. Okay, visited of ni and j. If any of this condition holds true, then we can continue. Okay, that we don't need to find for the cell, because there is no path from here, and this is out of bound, and it's visited. Now for if this is a valid next I and j index, so now we need to see from this particular cell, that the new cell that I have created, right, next I next j, from here where all I can go, and I, while going back, that is in reverse direction, if I tend, if I, by any chance if I come back to this I or j or not, if I can, which means this is my valid path, so I can further make DFS call. So I need to go over this direction, so for this next cell, so I would name it as reverse direction of directions for this grid of next new of I and new of j. Okay, so if this new I plus this reverse direction uh, you know value that we got is equal to I, or this new of j plus reverse direction of 1, that is the j value which it holds. If this value is equal to j, okay, then we can make the DFS call for this next ai and I and j, because there is a path from ij to next I next j. Okay, so DFS from next I or new I new j, and the same visited and grid we will pass. And further, if there was a path, I mean we were able to reach to end cell n minus 1 m minus 1 from this ni and j, then we can return true. Else not, we will continue exploring the next direction, And eventually, after trying all possible directions, still if we were not able to visit, which means there is no path where I can go from my current index. So I can return false from here. Okay. So this is how the code looks like for this problem. And if we discuss the time complexity, so time complexity is in DFS at max, we would be visiting, uh, you know, all the possible all these cells, which is like n cross m, and these loop if you see, right, so this is just two times, this will run two times because for every cell value we can go to two direction only, and similarly inside also when we check there also we can go two times only. Okay, so time complexity at max it would be O of n into m, considering these are just two times is linear kind of time. So yeah, and space complexity is we are having this visited array which is of size n cross m. So yeah, this is the space and time complexity for this approach. I hope you like this video. Thank you for watching. Stay tuned for next video. Thank you.